2 pi and then just an additional pi over 2. So this would be our 5 pi over 2. All right, so those are our basic graphs for sine and cosine. Now let's explain just a little bit more of why it gets this wonderful wavy motion. Our trig functions, of course, you can think of them coming from our unit circle. And if you want, you can think of the coordinates on a unit circle. Those are what's really generating our values that we're going to put on our graph. So imagine you were looking for the graph of sine of x, and you're going to use your unit circle to help you out in this process. You'd first want to think of what are some key angles on your unit circle. And since we are dealing with sine, you'd specifically wonder, hey, what are the y values? The process would be exactly the same if you were working with cosine, but then you'd work with the x values. So let's see what we get for some of our key values. When we're at an angle of 0, the y value would simply be 0. When we're at pi over 6, that's our first major angle there, we'd be at 1/2 for our y value. For pi over 4, I have square root of 2 over 2. And for pi over 3, looks like we're at square root of 3 over 2. And finally, straight up and down at pi over 2, we have a value of 1. Now, this corresponds to the values you see on that first little uptick of sine. So it starts off at 0, which is sure enough our y value at 0. And it starts increasing and increasing after that. And it gets bigger and bigger until it hits pi over 2. That's where it grabs that maximum. Now, as we continue around the unit circle, we'll see those same values show up again, but now we will be decreasing. That angle's sweeping around, and now we're getting smaller and smaller values for our sine. So sure enough, in the graph, now we're going to see this go down. It's going to get smaller and smaller until eventually, when we're right at pi, we get a value of 0. So this is at pi. As we continue to sweep around the unit circle, we get the same values, but now that we're below the x-axis, we're getting the negatives. So negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2. So almost the exact same shape, but now we're in the negatives. We bottom out right here. This is when we're straight down at 3 pi over 2. And then from there, we would imagine going back up, still in the negatives, but negative square root of 3 over 2, negative root 2 over 2, negative 1/2, and eventually returning back at 0 when we reach that angle of 0. So back up at 2 pi. And of course, that's just one trip around the unit circle. I could make another trip around the circle, in which case we'd just simply graph out the same shape a little bit further down. And I could have gone around the unit circle in the other direction, so we could even extend it this way. So the graph of sine extends in both directions infinitely, and you can see that really we're just keeping track of that y value as we go around the unit circle, getting this wonderful wavy motion. And again, the same thing would happen for cosine, but now we'd keep track of the x values. All right, some other things you may want to know about sine. This repeated section right here where it makes one full cycle, this is what we call the period of the function. And for sine, the period is 2 pi. Also, the maximum and minimum value, the way we keep track of that is we call this the amplitude. So we say that the amplitude is 1, corresponding to that maximum peak. All right. If you'd like to see some more videos, please visit mysecretmathtutor.com.